All right, so brand new chapter. We've got some new words in here. We're going to see some old words that we've talked about before, but we're going to do some things kind of similar, really. I mean, what we're doing in here, it's the same kind of stuff, except it's just different stuff, all right? So anyway, you'll see what I'm talking about when we get into this. So let's do this word first. Let's talk about the word transversal first before we get into parallel lines. So let's say I had two lines. Let's say I had one like this and one like that. Are they parallel lines? No, they're not parallel lines. Somebody tell me. I said we were going to do transversals first, but we might as well talk about parallel lines. It's sitting right there. What do I know about parallel lines? Somebody tell me what I know about parallel lines. Jaden?
That they go on forever and never meet.
They never meet. Correct. They never meet. These two lines go on forever, but they do eventually will intersect. Okay? That's what we say. Instead of meet, that's a good word, okay, when you're first talking about it. But eventually we'll just say that they don't intersect. Everybody got me on that? So that's what parallel lines are. Look at these two lines. What do you think is going to happen to these two lines? They're going to eventually do what?
Meet up.
Yeah, they'll probably meet up, right? If I took that and I extended it, look, they'll eventually meet, correct? Yeah. All right, let's say we had another line that intersects both of those lines right there. So let's say we had a line like that. Would you agree that that line intersects?
Yes.
Yeah. Right? It crosses both of those lines. So guess what we're going to call that? A transversal. Very good. It's right in front of you. All right? So that's considered a transversal. So anytime you have a line that intersects two or more lines, all right? So it intersects right here, intersects right here. Anytime you have a line that intersects two other lines, we call that a what? A transversal. Very good. All right, so this is a transversal. All right. You could have, what did I say? Just two lines? What did I say? Two or more, right. So I could have a line going like this.
Wait.
Is that still a transversal? A line going like that. Look at that red line. It's hitting all of those white lines, isn't it? All right, if it's hitting all those lines right there, that's considered to be a transversal. What were you going to say?
Nothing, I got it.
You got it? Okay. All right, so let's talk about two other lines that intersect each other and some of the angles they form. We're going to talk about this quite a bit. So what if I had just any two lines? Now these are lines, but I'm just being a little bit lazy and not doing what with them? Putting the arrows on the ends, okay? Is that all right with you?
Yeah.
Okay, so they are lines. They're not line segments. They don't have an end point. They keep on going. I'm just a little lazy, just didn't put the arrows on there, just for the sake of time. Now, I want you to take a look at some angles that are formed. Check this out. Do you see this angle right there? That angle is formed, isn't it? And look at the angle that is across from it. Okay, not right next to it, not adjacent to it. Did we use that word adjacent in here yet?
Yes.
Yeah, I think we did. Okay, not adjacent to it, not right next to it, but the one that's across from it. So if I name these angles, if I name that angle 1, 2, 3, and 4, all right? We don't have any points on there, so I can't use the points. I'll just name the angles like that. Which angle is across from angle 1?
3.
Angle 3. Now take a look at it. Now I don't have a protractor. I don't think. Well, I got a little plastic one in my drawer over there, but I can't use that with a projector, okay? But if I was to measure this angle 1 right here, tell me something possibly true about angle 1 and something else. What do you think?
It'd be more than 90 degrees.
Okay, it looks more than 90 degrees, but in relationship to the other angles, what do you think?
Angle 1 and angle 3 would be equal to
That's right, exactly right, okay? And that's a good observation. Angle 1 and angle 3 would be equal to each other, and they are equal to each other. I didn't even have to measure it, okay? Because I know that when I have angles, when I have two lines that intersect each other, the angles that are across from each other, and I keep saying across from each other, we're going to stop using that phrase here in a minute, okay? But just so that you understand, okay, the ones that are across from each other like this, they are equal to each other, and we have a special name for those angles. So I would say that angle 1 and angle 3 are called vertical angles. So any two lines that intersect each other, you have two sets of equal angles, and we call those equal angles vertical angles. okay? I'll put the little symbol for angle and then put an apostrophe S, okay? So this is vertical angles. Do you see another set of vertical angles in here? What are they, Molly? 2 and 4, 4 and 2, right? Doesn't matter how you say it. Angle 2 and angle 4 are also what? Vertical angles. And take a look at angle 2 and angle 4 as far as the measurement of them. I'll put 2 arcs there, okay? Just to make it different than the 1 arc. So I'll put 2 arcs right there. Look at angle 2 and angle 4. If I took a protractor, went up to both of those and measured them, guess what would be true about both of those angles? They would be equal to each other. Exactly, all right? So 1 and 3 are vertical angles. They're across from each other, and they're equal to each other. 2 and 4 are vertical angles. They're equal to each other. So what can I say about any vertical angles? They're always equal to each other, okay? Or in geometry, a lot of times, instead of saying equal, we'll say what? Equal with a little squiggle. What does that mean? Have we not used this yet? We congruent. Yeah, we've used that word, right? Yeah. Okay. Is congruent. Okay. So vertical angles are congruent. Now, I'm okay if you say vertical angles are equal to each other. It doesn't bother me that much. There are some geometry teachers out there that is going to bother them. All right. Just so that you understand. So vertical angles are equal, or you could say vertical angles are congruent to each other. Hold up, let me answer a quick text I had to answer. Okay, there we go. All right. So that's super important. You're going to see that quite a bit. It's something to look for. Anytime that you get 2 lines that intersect each other. Let's do this. Turn this back into white. Let's pop this up a little bit. I mean, look, if you, oops, there we go. Come on. Why, there we go. What if you had something like that? Are they 2 lines that intersect each other? Yeah. Absolutely, all right? And what do we know about this angle and this angle right here? They're equal because they're across from each other. Even though it's a whole lot skinnier than the other ones, they're still equal or congruent. And then you could say that this angle and this angle are congruent. Everybody got that? And you're going to see that quite a bit, especially for what we're going to do here in a second. So that's pretty important stuff. All right, now we're going to talk about this is a big deal. When I think of geometry, I think of a lot of different things, but this is one of the things that I think of, okay? This is one of the big things that you do in geometry. All right, we're getting ready to do it. Vertical angles is kind of one of those, but what about this? What if I have 2 lines? Now, did I say anything about those lines being parallel to each other? No, they're just 2 lines. Oops, didn't want to do that. Let's cancel out of that first. There we go. Now, let's change the color. And let's put a transversal in there. I don't have a transversal yet, do I? All right, because I need 2 or more lines and then a line that intersects all those lines. So let's do that. Let's put an intersection right there. We good with that? All right, I'm going to move this up a little bit. It got a little too far away. That's good. Okay, and I'm going to number a bunch of these angles. All right, so, and I'll just kind of put them in order. I'll go 1, 2, 3, 4 up here, and then 5, 6, 7, 8 right here. Okay, yes, every time, my goodness. Went through that today in another class. All right. It'd be nice if we actually said 6, 7 without you saying anything. It'd be really nice. So anyway, here we go. We got some names for these. All right, we got some relationships. Now, we already know one relationship. We know all the vertical angles are equal. So if I wanted to, I could list all the vertical angles that are equal to each other. What would they be? Angle 1 would equal what? Angle 4. Angle 2 would equal angle 3. Angle 5 would equal angle 8. And angle 6 would equal angle 7. Okay? Now, that's the only relationship that I know right now. Okay? It's the only relationship that I know right now. But I do have some names for some of the other angles. All right, we haven't even talked about parallel yet, have we? All right, we're going to get to it in a minute. After we do this, then we're going to do parallel. So we have some names for some of these angles. Do you see how these 4 angles are kind of like in a clump of 4? You see how they're all grouped together? And this is kind of grouped together as well. Would you agree? All right, so what I'm going to do is I'm going to make a comparison between the stuff up in this clump, for lack of a better word, and going to compare it to the angles down here in this little grouping. It's probably a better math word, or clump of angles right there. Logan? Grouping, yep. All right, so I should have made this a little smaller because I don't have a whole lot of room to write, but that's okay. Let's do this. So I want you to look at angle 1 and compare it to this grouping down here. Which angle looks like it is in basically the same spot as angle 1? I would say angle 5, because look at angle 1. If I was to describe angle 1 to you, I'd probably say this is in the top left of that grouping. Would you agree with that? Which one's in the top left over here? The 5 is. You see that? All right. And what about the 2? What is the 2? Okay. And then the 3 and the 7 and the 4 and the 8. Well, we have a name for that. We have a name for that relationship. Okay, there's a relationship between there because they're kind of in the same spot, aren't they? Everybody got that? Top left, top left. This is the top right, this is the top right. Bottom left, top or bottom right, bottom right. So they have a relationship between each other, and we have a name for that. And we call them corresponding angles. Write that down. This is going to be important to know these words. Okay, we call them corresponding angles. All right, let's list the corresponding angles. So angle 1, and what corresponded to angle 1? Angle 5, right. Now, did I say anything about them being equal to each other? No. Okay, they just match up, right? They correspond to each other. Does that make sense? All right, give me the other one. 2 and, we already said them, but I'm going to write them down this time. 2 and what? This is top right. Which is the top right down here? Angle 6, good. Okay, let's do angle 3. Angle 3 goes with what? Angle 8? Look, 3 is in the bottom left. Which one's the bottom left over here? The 7. So the 3 and the 7 go together. You see that? There's a relationship between them, okay? They correspond to each other. And I got one more, what's that? Angle 4 and angle 8 go together. So we call them corresponding angles. Does it make sense why they call it corresponding? Because they correspond with each other. They talk back and forth, corresponding, right? They match up, all right? Basically is the best way that I could think of saying that. They match up with each other, all right? So know those. Know which ones are corresponding angles. Now, we know the vertical angles. We already talked about that. I'm not going to write those down. Now, here's another one. Look at, I'll put the word down first, okay? Then we'll tell you which angles goes with the words. So here's another one. This is one, man, if you talk to people that haven't had geometry in 20 years and you say this to them, not everybody, obviously, but a lot of people say, oh, that's right, I remember that phrase. All right, this is a very, very kind of famous, I guess, geometry phrase. And we call it alternate interior angles. Alternate interior angles. And I'll just put the symbol for angles. What in the world is an alternate interior angle? Well, I'm glad you asked. Did you ask? Okay. So alternate interior. First of all, let's talk about which ones are interior, which ones are, what do you think the other one would be? Exterior. Good. The ones that are interior, the ones that are between those two lines. All right, you see that? See these two lines right here? So just tell me which ones are interior angles. 3, 4, 5, and 6. Okay, they're the interior angles. Make sense? So tell me which ones are the exterior angles. 1, 2, 7, and 8. Good. Now, what about that word alternate? All right, they mean they're all interior angles, but they're completely opposite each other. So let's take a look at angle 3. Angle 3 right there. Which one of those 4 interior angles are completely opposite? 6. You got it. Okay? So 3 and 6, they're alternate interior angles. One's on one side of the transversal, one's on the other side. But one's way up here in this grouping, and one's way down here in the other grouping. Do you see how they're completely opposites of each other? All right, so we don't call them opposite angles. What do we call them? Alternate interior angles. So if I asked you to list all the alternate interior angles. Let's do that. There we go. So angle 3 would be an, oops, forgot the number. Angle 3 would be an alternate interior angle with what?
Angle 6.
Angle 6. And then what's the other, we didn't circle it, but what's the other alternate interior angles? Angle 4 and what else?
Angle 5.
Angle 5, good. Okay? So if you look at the word and understand what that word means, alternate, all right? It means, well, alternate could mean like go every other or something, but it's the opposite, all right? It's not the ones right next to them, right? It's not the one right next to them. It's the one on the opposite side of the transversal. And if this one's above in that grouping, then you're matching it up with the one that's below in the other grouping. We already mentioned this, but what do you think is next? Instead of alternate interior angles, what do you think we're going to have? Right. I'm going to shorten that word. Is that all right? Alternate like that. Same thing with interior. Now that I've written it down. Whoops, not interior. What am I doing? What did you say?
Exterior.
Exterior, good. Alternate exterior angles. Is that all right if I just put EXT instead of exterior? Will you remember that? If you want to write down the word exterior, that's good. All right, so now let's do this. Let's get rid of these yellow circles. We already listed which ones were the exterior angles, 1, 2, 7, and 8. So which ones are alternate exterior angles? So let's take a look at angle 1. That's an exterior angle. Which exterior angle is completely opposite of angle 1? Angle 8, that's right. So angle 1 and 8 are alternate exterior angles. So let's list those. So angle 1 and angle 8. Have I said anything about them being equal to each other? No. I will in a few minutes, okay? But not right now. So give me my other, there's only one other pair of alternate exterior angles. What would that be? 2 and 7. You got it, see? You're catching on pretty quick. I got one more set to go over. Everybody catching on?
Yeah.
Okay. It's been pretty easy, right? Just learning what the words mean and the relationship between the angles. I got one more set. Now check this out. What about, what about 3 and 5? They're not completely opposite, are they? Both of those are on the same side of that transversal. Do you see how both of those angles are on the left side of that red line? Okay? So I'm going to give you two variations of this. I'm going to give you the one the book uses, but the one that I'm going to give you first, in another book that I used to teach out of, this is what they would call it, and I kind of like that wording better because it makes more sense to me. They call it, I hear the phone, it's the second time I've heard it, so you better shut it off, all right, because if I see it, all right, I'm going to take it. Just warning you. All right. Here we go. So 3 and 5. Almost hate to put this down, but I like this. So another book that I used to teach out of called them same side interior angles. Okay, or now this book calls them this. They call them consecutive interior angles. I kind of like same side because it kind of tells you exactly what you're talking about here. Same side of what? The angles are on the same side of the of the transversal. That's right. They're on the same side of the transversal, okay? I like that. They're interior angles, right? 3, 4, 5, and 6. Which ones are on the same side? Which interior angles are on the same side of the transversal? 3 and 5 and 4 and 6, okay? But this book doesn't use that word, okay? So we're going to use the word that the book that we have uses, all right? And it's called consecutive interior angles. So let's list those. So that would be angle 3 and what? Angle 5. And what's the other set? Angle 4 and angle 6. Everybody got that? And we don't really talk about consecutive exterior angles. I don't know why they don't, but they don't, okay? So would they just stick with the consecutive interior angles? We good? All right. Just a couple more things. We're not going to finish this lesson, but it was a good try, wasn't it? Good effort. Did you get all that?
No, I didn't.
Well, you could watch the video because I got to move on. I only got like 6 minutes left. Okay. So now, what was that whole lesson about? It was blank and transversals. Parallel lines and transversals. So now, finally, we're getting to the parallel lines. All right, so here's some parallel lines right here. And let's put a transversal. And we're going to talk about the same words that we talked about before. But remember, on this, were those two lines parallel to each other? Those two white lines, were they parallel? No, they're not. Okay, but now it's a little different, isn't it? Now they're parallel to each other. Let's put the same, let's go white. Let's put the same numbers in there just so we don't get confused. 1, 2, 3, 4, and then we'll go 5, 6, 7, 8. Now, just looking at this picture, just looking at the picture, without me saying anything, can you say that those lines are parallel to each other?
Yeah.
Why? How do you know? How do you know they don't meet? They could eventually. Maybe this one's off by like 1/10 of a degree compared to this one. And then eventually, way down the road, they're going to meet each other. Do you know that? You don't know that, do you? So you don't know, just by looking at this, that these are exactly parallel to each other. You have no idea. It looks like they are, doesn't it? Yeah, so I don't blame you for saying, yeah, they're parallel, okay? And they are parallel because I made sure on this computer program that they were exactly parallel. But you don't know. How would you know if they're parallel just by looking at it? What do they have to put in there?
The arrow.
They got to put the arrows in there, not at the ends, because I was just lazy, didn't put the arrows at the ends, okay? They got to have a set of arrows like this. Now, are these two lines parallel? Yes, okay? Now, they were parallel before, we just didn't know for sure. Now, do we know for sure that they're parallel? Absolutely, because they told us. Make sense? Always look for that. That could get a little tricky sometimes, all right? So yes, these two lines are parallel to each other, so we're good to go. Now, let me show you real quick the relationships between alternate interior, corresponding, alternate exterior, consecutive interior angles, all right? So, I'm just going to give this to you real quick. All the corresponding angles, when you have parallel lines, this only works when you have parallel lines cut by transversal. So if I have two parallel lines cut by transversal, all the corresponding angles, let's take a look at it. Give me give me one set of corresponding angles. Angle 1 and, no, 2's not corresponding. 5, remember, 1's in the top left, 5 is at the top left. Okay, you got it in your notes right there, don't you? All right, so 1 and 5 are corresponding. Now that these lines are parallel to each other, look at those two angles. Look at angle 1 and look at angle 5. They look exactly the same, don't they? And they are exactly the same. They're only exactly the same when what? When the two lines are parallel to each other. That's the only time that that's true. But when the lines are parallel, the corresponding angles are equal to each other. You could say congruent if you wanted to as well. Remember we did the alternate interior angles? The alternate interior angles? Guess what? Let's take a look at those. We're just looking at it. We're just eyeballing it. All right? We're not proving it or anything. We're just eyeballing it. Give me a set of alternate interior angles. 3 and what? 6. Look, that's acute. That's acute. It looks like they go off at the exact same angle, don't they? So what do you think might be true about alternate interior angles? They are also equal to each other. All right, so 3 and 6 are equal. 4 and 5 are equal. Let's go through the corresponding. So 1 and 5 are equal. 2 and what? 2 and 6, not 7. 2 and 6. They got to be in the same spot. Okay, they got to be in the same spot. This is in the top right. 6 is in the top right. That's corresponding. You got to get this straight. So 2 and 6 would be equal to each other. Angle 3 would equal what? Angle 7. Angle 4 would equal angle 8. Because of what? What's the reasoning? Because they are corresponding angles. Everybody good? All right. So alternate interior equals. So that means that angle 3 equals angle 6. Normally I would write all these down, but I'm running out of time. And then I would write down angle 4 equals angle 5 because alternate interior angles are also equal to each other. Same thing with alternate exterior angles. I'm not going to go through all that, again, because of time, but the alternate exterior angles are also equal to each other. The one set of angles that we've talked about, even the vertical angles are equal, right? Give me the vertical angles. 1 and the vertical angles is the first thing we did. Look in your notes. 1 and what are vertical angles? 4, the ones that are across from each other, okay? You got to study this. Okay, watch this video again. All right, read your notes. So 1 and 4 are vertical angles. They're equal. Angle 2 is a vertical angle with what? 3. 5 and 8, 6 and 7. So all the vertical angles are equal. Yeah. Why do we do that every time? I ask you not to do that. All right? It's getting old, okay? I know it's your little inside joke, but I'm privy to it now. I know about it. It's not that funny. All right? So knock it off. What's the other one? Consecutive interior angles. Now, let's take a look at a pair of consecutive interior angles. There's a little more I would do with this, again, if I had some time, but not going to. So give me a pair of consecutive interior angles. 3 and what? 5. Now, take a look at them. Take a look at angle 3 and angle 5. Are they also equal to each other like all that other stuff? Check it out. No. What kind of angle is angle 3 up here? Yeah, it's interior, but like it's acute. It's an acute angle, isn't it? Look at angle 5. It's obtuse. Is there any way an acute angle is going to equal an obtuse angle? No, there's no way. It's impossible from the definition of acute and obtuse. Okay, you with me? So, they're not equal to each other, but they are, I don't know if we use this word yet, but I'm going to write it down. Supplementary. Did we use that word? Okay, I'll tell you what that means. Supplementary. All right, get my spelling right. They are supplementary. Supplementary means this. Well, check this out. Watch this. I got a couple minutes. I thought we were done at 3. For years and years, we've been done at 3. Actually, my whole entire teaching career, we've always finished at 3. This is the first time it's been 3:05, so I forgot about it. Check this out. What if, let's say that angle 3 was, I don't know, what do you think that is? Maybe like 45 degrees? We'll just say it's 45 degrees. Is that all right? Yeah. Okay. What would angle 4 be equal to? I'll tell you what, let's make it easier to do the math. Let's just say it's 50. Is that all right? Just to make it easier to do the arithmetic. All right? So if that angle was 50 degrees, I should be able to find all the other angles. Let's try it. What's angle 2 then? Why? Why is it 50 degrees? Because they are what kind of angles? No. This angle and this angle are not alternate anything. What are they? They're vertical angles. Very good. They're vertical angles. Agreed? Okay, check this out. What about this angle right here? What is it, Zach? It's 130, right. Why is it 130? Because this makes a straight line, doesn't it? Right? How many degrees is a straight line? 180, all right? So this, my screen is going blank because I forgot to plug it in. That's all right, I got enough battery to last 2 minutes. So this is 130. Agreed? So what's this angle right here going to be? 130, all right? What's this angle right here? Remember, the corresponding angles are equal to each other. So if this is 130, what's angle 5? That's 130. What's angle 6? That's 50. What's angle 7? That's 50. What's angle 8? That's 130. Now, what am I looking at? I'm looking at the consecutive interior angles, all right, which is this one and this one. What do are they equal? Why are we packing up? We're not done. 50 and 130, are they equal to each other? No, they're not. What are they? They add up to what? They add up to 180. That's what the word supplementary means. It means that they add. Why is my thing acting so crazy? Maybe it's getting too hot. Yeah, my thing is going berserk. So they add to 180 degrees. All right, that's what supplementary means. All right, we'll stop there, and I need you to make sure you know those words. Okay, we're a little bit slow on the end, like with vertical angles and stuff. Go through it again. You don't have to watch every second of the video, but scan through it quickly till you get to this, so you remember which ones are corresponding: alternate interior, alternate exterior, and consecutive interior. Everybody got that?
Yeah.
All right, so make sure you're good with that, because we're going to do some examples when we come back.